number one is kind of a repeat of yesterday's. Oh, that was going to be Roman. I heard the door open. Because it's just asking us to find the remainder. So we're going to be using synthetic division to find the remainder. What in the directions, what are the coefficients for P of X? You guys know what I mean by coefficients?
Yeah, 3, 7, and -2.
3, 7, -2, 6. Numbers on the front. Okay. And then on number one, it says we're dividing by x minus 1. So if we're dividing by x minus 1, what did I put in the box yesterday?
1.
Positive 1. Okay, then we did that. Remember what we did? 3 plus nothing. 3 times 1. 7 plus 3.
So that's
10 times 1. -2 plus 10. 8 times 1. Okay. The question was, what's the remainder for 1 through 4? And yesterday we didn't have any remainder on these, but today we do. The remainder is 14.
That's crazy.
Can we just put like 14 or should we do?
Well, on the evens you do need to show some work, but on the odds I'm not going to be too picky. If you think you need it for notes, then you can put it. If you're feeling confident, you don't have to worry about it. Number 3. So yeah, guys, on the evens, make sure you show the work. Same thing, but we're dividing by x plus 2, so kind of recycle the coefficients. Now, if we're dividing by x plus 2, what goes in the box? Minus 2. Okay, so we're gonna add down 3 plus nothing. Multiply up 3 times -2. Add. Multiply. Add. Multiply. Same thing as last time.
Hey, Mr. Jordan.
Hmm.
What is your favorite math?
I don't know.
It's probably the one where he doesn't have, you know.
I bet it's geometry.
I don't know what it was with geometry. It was like painful.
Okay, number 5 says use the factor theorem, which we haven't talked about, to determine whether each binomial is a factor of blah, 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 blah. So, what does it mean for something to be a factor of something?
If it divides into it, or it multiplies into it.
Right, if it divides into it perfectly with like no remainder, right? So, like is 4 a factor of 20?
Yes.
Yes, because 20 divided by 4 is 5 with remainder, no remainder. Divides perfectly. So basically we're doing the same thing. If the remainder is 0, we're going to say yes, it is a factor. If the remainder is anything besides 0, we're going to say no, it is not a factor. So it's the exact same steps as numbers 1 through 4, but the answers are yes or no. What are the coefficients using the directions that we're going to use? 1. Alright, so you get 1, -10. What came after -10?
The
17.
Then what?
52.
Okay, what are we going to put in the box? On number 5, we're dividing by
Oh, -2. Or 2, just 2.
positive 2. We're dividing by x minus 2, so 2 goes in the box. Okay,
Wait, why did, on number 3, why do we have -2 in the box?
because we divided by x plus 2.
Oh, so it's like opposite.
Yep. Okay, so add down is 1. 1 times 2 is 2. -10 plus 2 is -8. -8 times 2 is -16. 17 minus 16 is 1. 1 times 2 plus 52 times 2. Numbers can get quite large on these. Doesn't really matter on this one if you have this number perfectly right, because the final answer is x minus 2 a factor of that big thing? Okay, if the remainder is anything besides 0, so basically what we just did was we divided the giant x to the 5th or whatever by x minus 2. This is kind of the answer to that. This is like x cubed minus 8x squared plus x plus 54, and the remainder is 48. But if it has a remainder when you divide, that means it did not divide evenly, and therefore x minus 2 is not a factor of this thing. So we're just going to put no. Okay, number 7, same thing. So we're going to use all those same coefficients. So I'm just going to.
Since when do you need a piece of paper?
And we're dividing by x plus 2, so I'm going to put negative 2 in the box. Add down, multiply up. Add down, multiply up. Add down, multiply up. Multiply up. Add down. Okay, the remainder is 0. What does that tell us? Tells us that yes, x plus 2 is a factor of that x to the 4th thing. It divided evenly. Okay, number 9, new section. This section says use the rational root theorem. Okay, this will be new to us. To list possible rational roots for each polynomial function. Let me copy down number 9 real quickly and we'll talk about it. Okay, so one theorem, one new rule that we're going to learn is that when you have a cubic function, there should normally be 3 answers to this function. Okay, whatever the highest power is, that kind of tells you how many answers there should be. If one of these answers is rational, do you guys remember what rational means?
Like it can be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
Okay, actually it's like 2/3, negative 5/4, anything that can be written as a fraction. So something that's not rational would be like square root of 2.
Pi.
So remember last chapter when we were solving quadratics, sometimes we got like 3 plus or minus square root of 2 over something like that. Those are irrational, those aren't rational. But if rational means like a normal answer, it could be 2, but it could be 2/3 or 5. It's normal answers, not square roots, not pi. If this does have normal answers, like not square root answers, you can find it with a trick. So what you do is you go to the last number, the constant, and then use the first number, the coefficient in front of the largest term. In this case it's a 1. Okay, you do factors of 6 over factors of 1. Factors of the last number over factors of the first number.
Oh.
What are the factors of 6?
Like 6, 12, those things?
No, those are multiples.
2.
1 and 6,
Oh.
2 and 3. 1 and 6, 2 and 3. What are factors of 1? 1. Okay, so the way you find the possible rational roots, this is called the rational root theorem, is it could be 1 over 1, 2 over 1, 3 over 1, 6 over 1. But what is 1 over 1? What is 2 over 1? What's
2.
two?
Or 1 and 2.
So when you divide by 1, it doesn't really do anything. So it's really just going to be 1, 2, 3, and 6. However, factors of 6 are not only do 1, 2, 3, and 6 can multiply into 6, but also -1 times -6 and -2 times -3. So these really could all be positive or negative. So 1 over 1 could be 1, so it could be plus or minus 1, plus or minus 2, plus or minus 3.
Hold on, Mr. Jordan. So why are we solving like this and not like how we have been?
Okay, because all the tricks that we've used in the past have been like quadratic formula. That's for a quadratic equation, like an x squared equation.
But this
And most of the factoring we've done, like this thing right here is not going to factor. Like we haven't learned a trick to factor. This doesn't factor. So the factoring trick won't work. The quadratic formula won't work because it's not an x squared. That's a quadratic. It's x squared.
So if the x wasn't cubed, we would be doing it the normal way?
If it was x squared, yes, we'd either do quadratic formula or factoring. And actually, we are still going to do the quadratic formula or factoring, but we kind of need to find one of the, remember I said there should be like 3 answers normally? What we're going to be doing is like finding one of those answers, and then once we get one answer, it'll get down to an x squared, and then we can do quadratic formula. I know that kind of doesn't make sense right now, but if there's 3 answers, if we can take one answer out, we'll be down to an x squared, and then we can do our old tricks after that. But this do trick is a way to find out, like, what's at least one of our answers. Okay, so how can we figure out which of these are actual answers?
Plug it in.
Well, yeah, you plug it in. So what we're looking for are which of these are zeros. Which of these makes this function equal 0? Okay, so really what we're solving is this. What x values make it equal to 0? So you can solve it by plugging it in, like plug in 1 and see if that actually equals 0. If it does, 1 is one of the answers. If it doesn't, we'll try -1 and just kind of keep going until we find an answer. However, on this section, we're not solving it yet. On this section, all we're doing is listing possible rational roots. So the stuff I was explaining is actually the last section. It takes a while to do it. So we're going to stop right there on number 9 through 12. Okay?
So it's just plus or minus 1, 2,
Yeah.
3, 4, 6, okay.
We don't have to plug it in yet. Almost, but not quite yet. Okay, 11 is short and sweet. All right, do you guys remember what I did to find the possible answers on 9?
Yeah, so you took 6 and you like found all the divisibles, so it's 8, which would be like 1, 2, 4.
Yeah. You do factors of the last number, assuming it's written in order. Factors of the last number over factors of the first number. I wish we should maybe do 12 instead of 11, because 12 is a little more complicated than this one. So let's do forget to do 11. I don't think I'm gonna write the whole thing down on 12, I'm just gonna write down the first and last. 4x cubed, blah, 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 plus 7. Okay, so what are we gonna do for 12?
So you're gonna put 7 and then the factors that go in 7.
Which is,
1, and it's only rational, right? Yeah, so 1 and 7.
yeah, it's called a prime number. Prime numbers are kind of good news because that doesn't give us a lot of options. Okay, and then factors of 4, what goes into 4? 1, 2, and 4. Does the order matter? Not really, but it's usually right from least to greatest.
Carolyn Schmerlin.
Okay, so this one's a little more complicated because the bottom is not just a 1. Okay, so we got 1 over 1 and 7 over 1, which are just 1 and 7. But then we have 1 over 2 and 7 over 2. You guys see where I'm getting this from? It could be 1 over 2 and 7 over 2. And it could be 1 over 4 and 7 over 4. You guys see how that works?
Yes.
Just got to get all the possible combos. 1 and 7 both over 1. 1 and 7 both over 2. 1 and 7 both over 4. So anyway, that's the answer to number, what was it, 12?
Yeah. Are we only doing half today?
We're going to do most of it because it's just the last part that takes a while.
So it's gonna be a 2-day assignment?
Yeah, probably.
Okay.
What if we just do it?
Oh,
Okay,
Yeah.
13. The A section is not hard at all. It's just the B section that takes a while. Okay, on 13, evaluate by synthetically dividing x minus a and applying the remainder theorem. So, this is basically just another synthetic division thing, but I need to explain that a little bit. Minus 26 plus 16. Okay, so you guys remind me, what does find f of 3 mean? What does this up here mean?
Function.
You have to try times 1 by 3.
Not exactly
I
now.
don't like the y.
Means what does a function equal when x is 3?
Yeah.
So it just means
Oh, you plug it.
plug in 3. Okay. What they're telling us to do though is use synthetic. So it turns out, there is a reason for this, but it turns out that you can also plug in 3 by using synthetic division, but they call it synthetic substitution. So it's basically just a little bit of good practice. When you're substituting though, you don't put in the opposite number in the box, you just put that number in the box. Okay? So it's a little bit different than division. You don't do the opposite of this, you just do this. And then the coefficients go across the top, so you do need to show work on this.
Yeah, guys, you have to show work. Get it? Because I don't show my work.
Because you could just plug it in normally or with a calculator, but they want us to do synthetic. And it's probably good practice, because we do have to do synthetic on other problems. Okay, so add down, multiply up. Carolyn, I'm sure you remember synthetic from yesterday. Add down, multiply up. Okay, the number that comes out at the end is the answer. Like 0 is the answer here. If we plugged in 3 normally, it should be 0. Okay, if we plugged in 3 normally, we should get this same answer. So synthetic can be used for division, and it can be used to plug a number in and see what you get. So this is no longer the remainder like it was on number 1. It's the answer. You guys get it? I'm thinking maybe we should do 1 of the B section today. How much time we got left? Yeah, I think I want to try 17 today. Okay, same thing on 15. However, there is a trick on 15. I think I might have mentioned this accidentally yesterday. Okay, there's something weird about what I'm writing on the board. What is weird about this?
It's half.
Nope, not that part.
You didn't put, you put a 0 in it.
Why did I put a 0 right there?
Because it's rational.
There's not like an X. They're not.
Okay, Jaden saw it. There's no x cubed term. So see how it goes 4 blank 2 1 nothing. So we're missing an x cubed term, and you need a placeholder for that, or else it won't work. So because there's no x cubed term, I put a 0 right there. Okay, is that going to happen on 16?
No.
No.
But 14 it will.
14. No, you're good on that one too. Let's see. The next time it happens. Dang, is that the only one?
Yeah, it is.
It's probably another
Wait,
odd.
wait. No, look at 21. What?
Yeah.
21, but that's an odd. But you guys need to know that because that's likely to appear on the test. Probably on the chapter review too. Mine actually might occur in the next assignment because next time it's like this one. Okay, anyway, I'm going to do the thing. Times a half plus 0 times a half plus -5 times a half. Okay. Let's see, did I make a mistake? Don't go too fast. I got it right. I was a little bit worried because I went too fast. It's not hard to multiply and add, but when you have to do it like 7 times in a row, it's easy to make a mistake. So just be careful. Okay, 17 is kind of like number 9, except we actually have to solve it. X cubed minus 5x squared plus 2x plus 8. Carolyn might not have been in here for this part. X cubed minus 5x squared plus 2x plus 8. Okay. We are supposed to find the zeros. The directions are we're supposed to factor it, but basically we need to find the zeros of the function. So we need to figure out what would make this equal to 0. So do you guys remember the trick from number 7 or number 9 or whatever? What are possible zeros of this function? It's called the rational root theorem. We're going to do factors of 8 over factors of 1. So you use the last number and the first number. Last coefficient and the first coefficient. Factors of 8 are
1, 2, and 4.
1, 2, 4, and 8. Factors of 1, 1. So it's 1 over 1, 2 over 1, 4 over 1, 8 over 1. But it could be positive or negative on all these. So those are possible roots, possible zeros. How do I figure it out if it is?
Plug it in.
Plug it in. So we can plug it in the old-fashioned way, like put in 1 here and here and here and just see if it equals 0. Or we could do synthetic. 1 is kind of easy to plug in, so I'm going to do it the old-fashioned way, because what's 1 cubed?
1.
Like these just turn into 1s, so it would just be like 1 minus 5 plus 2 plus 8, because 1 times 5 is just 5, 1 times 2 is 2. So that doesn't work.
So erase number 1.
So 1 is like not an answer. I might try -1 the old-fashioned way. -1 cubed is -1. -1 squared is 1 times -5. -1 times 2 is -2 plus 8. Does that work?
No.
Actually, we did it.
Yes, that does equal 0. Okay, so -1 is one of our answers.
So how do you do it the non-old-fashioned way, so you don't have to do that?
Well, we kind of still need to do it the not old-fashioned way,
No.
which is synthetic. So I know -1 is one of my 3 answers, and I know there's probably going to be 3 answers because of that. So what I need to do though is kind of take out the -1 as an answer, and I'm going to do that with synthetic. This is basically synthetic division. Before I do this, let me try to explain it. This always goes over people's heads, but I'm going to try. So you guys remember back when we were factoring, like last chapter, maybe did a little bit of this chapter, like what were the answers to this? What would the answer to this equation be?
2x.
Now, -2 and +3, right? Okay, so if I know that -2 is an answer, then I know that x plus 2 is a factor. So if I divide this by x plus 2, I know that I should get my remaining factor, which contains my remaining answer. Does that make sense?
Yeah.
Okay, I know -1 is a answer. Therefore, I know that x plus 1 is a factor. You guys see what I'm saying?
Yeah.
So what I'm really doing here is synthetically dividing x plus 1. And what will remain is question mark, is these last 2 factors that contain my last 2 answers. I'm dividing by x plus 1 till I get rid of this guy so that I can be left with these 2 guys. Okay, but these 2 guys will be basically left in a quadratic form, and I can solve quadratic using quadratic formula or factoring. Okay, so I know that's confusing, but basically the steps are just, if you know what one of the answers is, we're going to divide it out with synthetic division. I know -1 is an answer. I'm going to get rid of that answer because it'll help me find my last 2 answers. Okay, so do synthetic with that -1. And if we do it right, the remainder should be 0. Because I know -1 is an answer, and I know x plus 1 is a factor. So if we divide correctly, this should come out as 0 as a remainder.
Calculation.
All right, Do you guys recall from yesterday, what do these numbers stand for? Or was that 2 days ago?
I think that was yesterday.
That was yesterday.
6 and negative 8.
This stands for the constant, the x, and the x squared term. Okay. This little equation contains my last two factors and my last two answers. I don't need to use rational root theorem anymore. I don't need to use these, although I could, because this is an x squared and I know how to factor it, or I know how to do quadratic formula. So once you get it down to x squared, like the last two, you don't need the old tricks, or you don't need the new trick of rational root theorem. You can just do old tricks. This looks like it factors because what multiplies into 8, that adds up to -6. So x equals 4, 2. Okay, but don't forget, there was actually another answer that we knew. You guys remember what it was? -1. Okay, I think I'm gonna have us stop there. That's not where the book stopped. What the book wrote was, what's the factored form of the polynomial, which is this. They basically just took these answers and wrote the factor version of it.
Do you want us to do that?
I think I want us to stop right here, actually.
Fine, I guess we'll stop.
It's like the quickest bathroom break ever. There is a 0% chance you washed your hands.
Oh, I definitely did.
He said a 0% chance.
We got that on the recording too.